Hello everybody, getting ready to do lesson 9.7 of Algebra 1 Math, solving systems with quadratics. It's part 1. If you want part 2, part 3, email me here. 9.7, solving systems with quadratic equations. Here is our standard. This is part 1. We have a 42-point skill sheet here, and we have a 0 points of note-taking. Teachers, here's your bell work for today. Solve the equation, use quadratic formula. Check the solution for both of these. Give your students 5 minutes. Okay, here we're going now. This is number 1. This is your plug-in for your quadratic equation, and you should have plus or minus square root of 6 over 3. So this is your solutions for the first one, and then here's your check. You plug this back into the original and it checks out. And then for the second one here, you plug in your values into your quadratic formula. You get negative 3 plus or minus radical 27, and you get these two solutions here. And then our check is even more sophisticated in finding the original solutions. We plug that into our original quadratic and we get a 0 equals 0 again. So that would be your work there for your bell work. Solving systems with quadratic equations. You solve systems of linears. You will solve systems that include a equation. You can solve systems of linear equations using graph and check method and using the substitution method. You can use both of these techniques to solve a system of equations involving nonlinear equations such as quadratics. Recall that the substitution consists of 3 steps. Solve one equations for one of its variables. Substitute the expression from step 1 into the other equation and solve for the other variable. Substitute the value from step 2 into one of the original equations and solve. Like a 3-step process. Use substitution method. Here's our system here. Solve one of the equations for y. Equation 1 is already solved for y, so just substitute that into equation 2 and solve for x. So y equals 3x squared plus 6x plus 2. Then we just stick this in for y and then solve for x. Then we come up with this, 0 equals 3x squared plus 3x. Then we factor out 3x, we get that. So x equals 0, or x plus 1 equals 0. X equals 0, x equals negative 1 would be our two solutions there. Substitute both 0 and negative 1 for x and 1 and solve for y. We know our x, now we got to solve for y. We plug in our values there and we get y equals 2 and y equals negative 1. The solutions are 0, 2, negative 1, negative 1. Here is a graph of it here. So we have two intersections here on our parabola with a line, and those would be your solutions. Intersections, negative 1, and y equals negative 1. Negative 1, negative 1, and 0 and 2. So right up here, when x equals 0, y would equal 2. Okay, so got to practice now. We're going to do a guided practice. Students, pay attention so you can solve yours down here. There's our two equations. Substitute 2x squared minus 3x minus 2 for y in equation. Y equals x plus 4, then solve for x. So 2x squared minus 3x minus 2 equals x plus 4 for up here. Yep, that's what we're going to do. So we do that. We combine like terms. Then we factor out 2. We get these two here. So x plus 1 equals 0, or x minus 3 equals 0. So x equals negative 1, 3. Now substitute negative 1 and 3 for x in the equation. Y equals x plus 4. And we get, when we stick in negative 1, we get y equals 3. And then y equals 7. for the two solutions there. Now, solutions are -1, 3, and 3 and 7. We can use a graphing calculator to check these. Intersection -1, 3, when x is -1, y is 3. That would justify that one there. And then over here, that must be this one here, huh? When x equals 3, y. Points of intersection. When you graph a system of equation, the graphs intersect at each solution of the system. For a system consisting of a linear and a quadratic, the number of intersections and therefore solutions can be 0, 1, or 2. Systems with one linear and one quadratic, there are 3 possibilities for the number of points of intersection. We have this situation here with no solution, and then this situation here with one solution, and then we have a 2 solution possibility here for the linear and quadratic situation. So using a graphing calculator to solve a system, we have this system here. Enter each equation into your graphing calculator, set y1, and then y2, say. Graph the system and set a good viewing window for the system. A good window in this situation here would be -10, and blah, blah, blah. And then use the trace function to find the coordinates of each point of intersection. Here's what we have here. So using trace, or you could find intersection in your calculator too in one of your menus. But if you're going to use trace, this is one way of doing it. Intersection, x equals 1, y equals -2. But this is what it should look like in your viewing window. So the solutions are 1, -2, and 5 and 6. So now checking these, you can put these back in. So you're checking 1, and that checks there, and then checking here for 1, that checks there for x. And then our next guided practice here, solve these systems first by using substitution and then by graphing calculator. Okay, so there's our situation there. Substitute x squared minus 6x plus 11 for y in the equation y equals x plus 1, then solve for x. And then this is our setup. And then we're going to solve for x here. We can factor this into this. So now we got 2 solutions here for x. X equals 2, x equals 5. And then now substitute 2 and 5 for x in the equation x plus 1. So we have this here. 2 plus 1 equals 3. And then we have 5 here. So we're going to substitute 5 in and we get y equals 6. So there's probably our 2 solutions right there. When x equals 2, y equals 3. And then on the other one, when x equals 5, y equals 6. And they've been verified here by a graphing calculator as well as algebraically up here. That was part 1 of 9.7. You need part 2, part 3, email me here. Thank you.